In this lecture, we're going to explore pointer to characters. And you can declare a pointer to a character just like this. We have char pointer, and we say pchar to give it a variable name. We initialize this with a null pointer, and after that we set up a character variable, and it is called char, and we store in an A, an uppercase A. After that, we take the address of char and assign that to our pointer variable. This is how we store data in a pointer, and we can go through this pointer to access data in this character variable. If we do something like this, we're going to print A. Down here, we declare another variable, we store in a C, and we assign the address of this new character variable to our pointer variable. And if we print this again, we're going to get a C printed out. This is really what we have done in the last lecture. We are just extending that to character pointers. But with character pointers, you can do something really special. What you can do that is special, you can initialize that with a string literal. Something like hello world, which is wrapped in quotes like this. When you do something like this, the string here is going to be expanded into a character array, and the first character of our array is going to be pointed to by pmessage here. This is what we mean. I realize I might be throwing a lot of things at you right now. I am mixing up arrays and pointers, but they have a really strong relationship, and we're going to learn about that in detail in a few lectures ahead. But for now, think of it like this. This hello world string is going to be turned into a character array, and pmessage is going to point to the first character in this array here. This is what is going to happen. And this is going to give us the flexibility of treating our strings as character pointers. And this is going to come in handy at many occasions. One thing I should tell you though is that some compilers will refuse to compile this code. For example, Visual Studio 19 that I have installed on my computer right now is going to refuse to compile this code. And the reason is the compiler is going to expand this string into a character array of const char. And here, what we are using to point to that is not a const char pointer. So this pointer here can be used to try and modify data into an array of const chars, and that's going to be disastrous, because if you try to modify that, that's going to fail, and that's not going to be good. So some compilers are going to try and protect you from this and force you to use pointers that are qualified with const to really mean that they are const char pointers. And to get the code to work, we will have to do that, and I will show you how we do that in Visual Studio Code. But I had to tell you this, in case you just want to jump ahead and try this code out. If you get a compiler error, that's going to be the reason. Now that we have our string stored in memory, we can really print it out like this. If you print pmessage, you're going to get the string printed out. But I want to give you a question here. What do you think we will get if we dereference pmessage? Try to think about this. I told you that the compiler is going to expand this hello world string into an array of characters, or to be specific, an array of const chars. And pmessage is going to be pointing to the first character in that array. So if we dereference pmessage, we're going to get that character printed out. In this case, we will get an H. And that's what is going to happen here. But character pointers are special in that if you print them out directly, the compiler is going to do its magic and make it possible to print out the entire string that is stored in pmessage here. That's how character pointers are special, and you really need to be aware of this, because this is going to come in handy many times. Just to emphasize that this is going to be expanded into an array of constant characters. If we try to modify something inside pmessage here, for example, we try to change the H into a B, we can try to do that because pmessage is pointing to the first character, so we can try to dereference and assign a new value. And if we do that, we're going to get a compiler error, or even worse, we might get a crash at runtime. So this is something you shouldn't really do, and you should really flag your pmessage here as the const char pointer, and that's going to prevent you from doing things like this, which may turn out to be very bad. But most compilers are going to even prevent you from compiling this thing in modern times. For example, if you are using a very recent version of Visual Studio, you're going to get a compiler error. But I don't believe GCC is going to give us a compiler error. So we will have to try this out and see how it behaves. But the message is, if you have to do something like this, make sure you use the const char pointer and you're going to be playing on the safe side. Okay, now I think you know enough about character pointers. What if we want our users to be able to change this string and make it be something else? For example, change the first character here into a B. Well, in that case, don't use character pointers, use regular arrays like we have seen before. So you can set up an array like this. It's going to be a character array, and you can initialize it with a string literal, and this is going to allow you to modify things inside. So if we do something like this, we will get the message printed out, and the message is going to be tello because we changed the H to be a T. And this is going to work. So this is something you really need to be aware of. But character pointers are very helpful in many cases. And in most cases, you just want to store the string and print it out. You're not interested in changing it. So that's why this is going to come in handy in a lot of occasions. Now that you know this, we're going to head over to Visual Studio Code and actually try this out. Okay, here we are in our working folder. The current project is pointer to char. That's what we are exploring here. So we're going to grab our template files and put them in place. And we are going to open this thing into Visual Studio Code. And we're going to jump into here and set up our first const char pointer. Let's do char pointer to see how this thing behaves. We're going to call this message. And we're going to initialize this with our trusty message here, hello world. Okay, once you do something like this, your string is going to be referred to by message. Let's try and compile this and see that GCC is happy. We can compile with GCC, and it's going to tell us we can't really do that. And this is really good for base converting a string to constant char pointer. So what we are doing really is making an array of const characters and refer to it as a char pointer. And this is not going to work. This is a good thing. So you can't really do this, and this is a good thing. And let's try and see if Visual Studio can actually do this. We're going to build with MSVC. In this case, let's delete Looster. Before we do that, we can right click to it and say delete. Let's click to it first. Make sure it is selected and hit delete to remove it. Move to recycle bin in this case. Now we're going to clear here. Let's bring up our terminal again. And we're going to clear. And we're going to build with GCC. We're going to choose the MSVC compiler. If we're trying to build this, build finished with errors. And the error is going to be basically the same thing. This line here won't work. What we can do is make this const and make it super clear. That message here is going to point to an array of const char. If we try to build again, I think we're going to be good now. So let's try and do that. We're going to build with MSVC this time, and build finished successfully. Now this is really cool, and we can print this out. We can say stdc out message, and we're going to say message, and this is going to work. Let's go back to GCC because that's my favorite compiler. And you see that the compiler from Visual Studio is going to clutter our folder here with a lot of files. We don't want that. What I'm going to do, I'm going to select all this clutter here and remove that. And I'm going to hit delete with the right click, and it's going to go away. We're going to go back to GCC and use it and build with GCC. The build is going to go through because we qualified our character pointer with const here, and everything is going to be good. Be sure you know what is happening here, because this kind of problems can be really hard to solve. Okay, now that we have this, we can try and change something inside, but the compiler is not going to allow it. So if we try and do something like this, is not going to work because message is a pointer to const char. and we can't go through this pointer to modify something, so we're going to get a compiler error. This is something you should know, but we can dereference this pointer and print something that is inside. And I want you to guess again and see that you can come up with what is going to be printed if we dereference message and print out when we run this program. If we have this thing printed out here, again, we are dereferencing the pointer and printing whatever result we get from that. Remember that this string literal is going to be turned into an array of const chars, and the first element of that array is going to be pointed to by this message char pointer here. So if we dereference this thing, we should get the h here printed out. That's what I think we should get. Let's try and build with GCC, of course. The build is going to be good. Let's clear and run rooster. See that message is h. This is exactly what we expect here. Now that we have this working, what if we really want this thing here to work? What if we wanted to allow our users to go through this message thing and modify what is stored inside? Because sometimes that's going to be useful. Okay, we wanted to allow our users to modify this string. If you want to do that, you can use row character arrays. And the way we do that, we can say char message1, and we can make it an array and initialize that with hello world. And once we do this, we can go through the angle bracket syntax and modify the first character or whatever character we really want to modify in this string here. In this case, we are going to target the first. So we're going to say message1, and we're going to grab the index 0 because that's going to be the first character here. And we're going to assign a new character, let's say B, like we just said. And if we print this out, say message1, and put that out, we're going to see what comes out. If we run this program, we're going to build with GCC. So let's do that. The build is good, so we're good here. If we run, we're going to get below printed out, and we have successfully changed this thing here. So if you don't want to allow modifications to your string, use this thing here. If you want to allow modification to your string, use this syntax here. And this is really all we had to say in this lecture. We are going to stop here in this lecture. In the next one, we're going to see how we can work with arrays of pointer to char. Go ahead and finish up here and meet me there.